Hi everyone, can you just confirm if audio, video, everything is fine? Just let me know. Hi everyone, good morning. Okay, so we will now solve all the questions of Gate DA AIMT one that we have asked. Before that, just let me know if everything is fine. Okay, if you are able to hear me, if everything is fine, can you just quickly confirm me so that I can just start? Okay, so let me know if audio and video is fine. Okay. So, good morning. Good morning, everyone. Hi, Krish. Hello, Raj. So, I hope you people can hear me, right? So, now let's just get started. Now, before I start, just let me know if you found this, AIMT to be very helpful. If you found this AIMT to be good or not. Okay. So, just let me know. So, what was your experience with this AIMT? Yes, so maybe some of the questions you might have found challenging, but mostly I kept this AIMT to be easy to moderate level only. So I have not kept this AIMT to be honest. I have not kept this AIMT to be tough. I have kept it to be easy to moderate level only. Okay. So maybe some of the questions you might have found tough, some of the questions you might have found easy. But let's just see. Okay, solution of almost. I mean, we will see a solution of all the questions. So currently in this particular session, it will be the part one. Here I will be just solving till question number 45. Okay, till question number 45 I will be solving, and then later on in the sense that in the evening session I will just announce the timing later on, so till I can say question 45. Okay, and later on we will be solving the all the questions. So we will be solving all the questions. It is not just that we will be only solving few of the questions. Okay, so we will be solving all the questions live. So now let's just get started. Okay, how many of you were able to solve this question? How to solve this question? What they're saying, there is a multi-class logistic regression, right? So can you see the whole screen? I think everything is fine, or there is any problem. Okay, okay. So I feel that everything is fine, right? Okay. So just let me know if there is any issue with audio, video, or anything. Okay. So what I'm saying, that here you can see this is related to multi-class logistic regression, right? Now in multi-class logistic regression, what we do, it is same as you can say softmax regression. Okay, softmax regression. So we find out the probabilities using the softmax. So what we will be doing, so for every class there is a vector, right? This is a vector for class A, this is a vector for class B, this is a vector for class C. So by the way, this question I've taken from MIT. Okay, so maybe I can just paste the link here, but it's not required. I mean, you don't need to check the links and all. I'm just telling you that this question I have taken from MIT. Okay, so this is question number 14, right? Okay, so maybe I can just let you know the links and all. But yeah, so this is easy question, I guess. So they are asking about multi-class logistic regression, and in the multi-class logistic regression we know that we use the softmax function, right? So currently actually we don't need to even use the softmax because we don't need to normalize, but we can see that okay, we can just we can just find out w transpose x, right? Or maybe theta transpose x. So if you just do this theta transpose x, then you will be getting maybe this is the x, which is 1 minus 1 1. Maybe I can just tell you. So if you just do the dot product between these two, so it will be, you can say, theta A transpose x, it will be theta B transpose x, and then we will be having theta C transpose x, right? So what will the theta A transpose B transpose and C transpose x? Theta A transpose x, it is 1, right? Because if you just do dot product between these two, and then this will be minus 1, and then this will be, I think, minus 1 and 1 0, right? So this is 1, this is minus 1, and then this is 0, this is 0. So we have got three numbers here. Okay, so theta A transpose x, theta B transpose x, and theta C transpose x. Okay, one is 1, another one is minus 1, another one is 0, right? Now what to do with these numbers? Do you remember what to do with these numbers? So see, if they have to tell you that okay, which one is the maximum, okay, then I mean, if you have to classify based on just this, I mean, you can definitely do it. You can say it is belonging to class A because this is the maximum, right? But if you have to find out, let's suppose the probability of being into class A, right? The probability of being into class A. So what is the probability that it is in the class A, right? So what you can do, you can find out using the softmax. So what you will be doing, you can see this is a vector, okay, which is 1, -1 and 0. Now you can apply softmax on top of it. How to apply softmax on top of it? You can do e power, right? So here it will be e power 1 upon e power 1 plus e power -1 plus e power 0, right? Similarly it will be this next thing will be same as the first thing, but it will be e power -1, and then normalization factor, it will be same, e power 1, e power -1, e power 0. So what are these are the basically, it will be e power 0, e power 1, e power -1, e power 0. So what are these numbers that I am writing here? What is this number? This is the probability of being into class A. Okay. Now since this number is highest and this is just the increasing function, so this e power 1 will be always the highest. So that is why you can directly say that okay, since this is the highest, so it is belonging to class A. Okay. But if they ask you to find out the probability, then this is the way to do it. Okay. I'm also telling you that how to find out the probabilities. Although although they have not asked in this question, but if they ask, okay, if they ask in some other question, then you can you can do something like this. Okay. Yes. So, by the way, what was your marks? Or maybe I can just, ask you that maybe, I mean, but see, when I'm asking the marks in the AIMT, I'm not, I don't mean to, have any judgment or something. I just wanted to ask you your marks because I can just tell you that if they, I mean, what you can do based on these marks. So for example, if you are getting, let's suppose in this AIMT, if you are getting with range of 30 to 40, then don't worry. Okay. The reason is that, see, if you are getting, let's suppose below 40, okay. So since it was just first AIMT, okay. So it was just first AIMT. So don't worry. Your marks will get increased. If you see Piyush post who has got, AIR 1 last year in Gate CS. Okay, so Piyush has got AIR 1 last year in Gate CS. So if you see Piyush post, he has got in AIMT 1. He has got so actually he has posted on LinkedIn. Okay, recently he has posted. So in AIMT 1, he has got I think 53 something marks, and in Gate. Okay, I mean eventually he was increasing. It was almost more than 1 month, and in Gate CS he has got 91 point something marks, right? So you can see there's a lot of scope of improvement. This improvement is not because your conceptual knowledge will get increased or something like that. Okay, yes, maybe some little bit of your conceptual knowledge will get increased in this remaining 1.5 months. So 45 days are remaining, right? 45 days are remaining. So definitely your conceptual knowledge will get increased. But more than that, okay, more than the conceptual knowledge, in this 45 days, you will get to learn how to reduce silly mistakes. Reduce silly mistakes, how to recall concepts. Okay, how to recall concepts during exam. So these things you are anyway going to learn, and once you are used to these things, your marks from below 40, it will increase. Okay, it will definitely increase, right? So whatever marks you have got in the first AIMT, don't worry about it. And yes, so I think Sajan is here. So hello Sajan, good morning. So he has actually got top rank in AIMT 1, so congratulations to him, right? So yes, so let me just paste that particular message. Sajan is saying good morning. So basically he is our complete course enrolled student, and he has got a all India rank 1 in AIMT 1. Okay, so he has got AIR 1 here, in the sense that in the all India mock test. Okay, not in Gate. So in Gate definitely he will be getting top rank, because if he is getting top rank in AIMT, then it is a one way implication for sure, in the sense that if you are getting top rank here, okay, top rank in AIMT, then definitely you are going to get top rank in Gate. But obviously it is not saying other than, okay, or it is not saying anything other than this, which means that if you do not get top rank, okay, so basically you might have seen this A imply B things in the discrete mathematics in the I think this will be in the propositional logic. If A implies B is true, it doesn't mean that not A implies not B is true. Okay, it doesn't mean something like this, which means if you do not get top rank here, it doesn't say anything. Okay, in the gate, it doesn't say anything. So it is just a one-way implication. Okay, just a one-way implication. If you're getting top rank, then definitely I mean, your concepts are good. You have already reduced your silly mistakes. You are able to recall the concepts like this, right? So you will be getting top rank in gate. But if you are not able to perform, let's suppose in AIMTs, it doesn't mean anything that you're not going to perform in gate or you are going to perform in gate. Okay, so don't worry about your marks in the AIMTs particularly. Okay, so now let's just solve next question. So what they are asking in this question, this was related to Python. I think this was easy question. They are just asking you to slice from beginning. Okay, from beginning, because the initial index is not given. So from beginning to uh, to -1. So if you know that here in Python, we either see there are two ways of indexing. This is 0, this is 1, this is 2, like this, right? The second type of indexing you can do from the reverse. So this is -1, this is -2, and something like this. So if you're writing -1 here, what does this mean? It means that you will be taking all but not -1. I mean, this last index is not taken. So you will be taking from start to all but not this 5. Okay, so B is not the answer, A is the answer. Okay, so B is not the answer, A is the answer. Okay, and here in Python, okay, I have already told you, so I'm not going to much detail here in this particular session. So this, if you want to reverse this string, so there's a particular way to do it, which is like basically using two colons, right? Using these two colons, right? So if you want to reverse this string, then you can use something like this syntax. So we have already discussed these kind of syntax in detail in the lectures. So which means if you are just having one column, this A is the answer. But suppose you are having two columns here, then what will be the answer? The reverse string will be the answer. So D will be the answer in this case. Okay, in this case D is the answer. Understood? Okay. So now let's just see this question. This question basically was easy question, but some of the people have found it challenging, or some of the people have found it tough. The reason was that because of this order of n square, they are thinking that okay, merge sort always gives you order of n log n, which is fine, right? Which is fine, but order of n log n doesn't mean that we can't write order of n square. So basically, this option is also true. The order of n log n, if I'm saying that it is taking order of n log n, then definitely I can say it is also taking order of n square. Order of n log n is the tightest bound. I completely agree about it. Tightest bound I can say, right? But I can definitely say order of n square. I can definitely say order of n power 4. See, if something, let's suppose merge sort time complexity is less than equal to n log n, right? I mean, in all the cases, it take n log n. So let's just say it is less than equal to n log n, right? So it is definitely less than equal to n square, right? So if I'm saying less than equal to n log n, which means I'm saying order of n all log n. So I can definitely say it is order of n square. Okay. Now tell me, can I say merge sort time complexity? Merge sort time complexity theta of n log n. Can I say? Does merge sort take the n log n in all the cases? If I'm not mentioning that, okay, whether it is worst case, best case, it means in all the cases, is this taking n log n in all the cases? Tell me. Yes, right? So this is true, but can I say okay, let me just ask you again. If I'm saying theta of n log n, this is true, can I say the merge sort time complexity is order of n log n? Yes, this is also true, right? This is also true. Now let me know. Can I say it is theta of, sorry, order of n square? Yes, this is also true. We have just seen. Now let's just see the last case. Can I say its time complexity is also okay theta of n square? Can I say something like this? Is this true? See, this is true, this is true, this is true, but is this also true? Theta of n square. This is actually false. Okay, it doesn't take theta of n square. It is not taking equal to n square. Theta means equal, right? It is not taking equal to n square. It is taking less than equal to n square, which is true. Okay. So I hope that is understood to everyone. Now let's see this question. This question was, I think, easy one only. So in this question, they are saying that we have given, a few of the emojis here, and this they are saying that in the red they are writing the hash code here. So it was 5. See, number of buckets. Okay, so number of buckets n equal to, I can say, 5, right? Number of buckets. So maybe people might have done mistake that okay, n is 4, n is 4. Maybe some people might have done mistake that okay, n is 4 just because 4 is written here. So number of buckets is actually 5. Now they are giving you the hint that okay, which kind of hash function they are applying. For 5 it is mapping to 0, so most probably it is mod 5, right? Mod n. So whatever the hash code you have, mod n is your bucket number. This is your bucket number, right? So here you can say that that in this particular case, that okay, this 5 mod 5 will be 0, so that's true. 1 mod 5 will be 1, right? 3 mod 5 will be 3, 10 mod 5 will be 3, 28 mod 5 will also be 3. So yeah, that's fine. So 9 mod 5 will be 4. So these are anyway satisfying. Now they're asking for minus 6, right? So now the question is for the minus 6. So now they are saying, let me just go to the next page. Now they are saying that what if we are having any emoji with the minus 6? So what will you do here? The minus 6 mod 5 you need to find out, right? So if there is a negative number, okay, and you're not comfortable with the negative number and you want to find out the mod, what you can do? See, one thing you know, that let's suppose I want to find out x mod 5. Can I just say it is same as, it is exactly same as, okay? It is exactly same as x plus 5 mod 5. X plus 5 mod 5. Can I say something like this? Let me know. See, whether you write x mod 5 or x plus 5, which means even if you add something, because this plus 5 mod 5 is anyway 0, right? This mod 5 is anyway 0. So basically you can even add 5 one time, you can even add 5 two times also, okay? Which means 2 into 5 mod 5. Like this. You can add 5 any number of times here, right? So if you're not comfortable with this negative, what you can do, you can add 5 here, okay, one time or maybe two times. So let me just add it two times. So it will be 4, and then you find out the mod, okay? So it will be 4 is the answer. Is this okay to everyone? Let me know. Is this fine? Right? Okay. So now let's just see the next question. I think this question was easy one. So what they're saying, you just need to push 35, then push 36, then push 43, then push 8, then pop. Okay, so if you pop, this will be out, this will be out. Then push 51, then pop. So I think 36 and 35 is remaining, right? So 35 and 36, yes. So I think only one option is matching. So A is the correct answer here. It was an easy question only, right? Okay. Now let's just move to the next question. So what they are saying, in this question they are saying that SVD of X is given to be something like this, then which of the following are always symmetric? Okay, so this was MSQ question, by the way. This was multiple select or MSQ question. So let's just find out whether U transpose X is symmetric or not. So first of all, substitute this X with the SVD, because then only you will be able to solve this question. So for U transpose X, you can say it is same as U transpose U sigma V transpose, right? Which is same as, see, U is containing orthogonal vectors. See, if U is containing orthogonal vectors, which means U is column vectors basically. Let's suppose U1, okay? Let's suppose this is U1, this is U2, this is U3. Okay, then what is U transpose U? U transpose will be, this will be U1. I mean, this will be U1 transpose, this will be U2 transpose, this will be U3 transpose, right? This will be U3 transpose. And then this will be U1, this will be U2, this will be U3. Okay, so U1 transpose into U1, this will be the, if this is the orthonormal vector C1, then this will be the identity matrix 1 0 1 0 0 0 1 0 0 0 1, right? This is the identity matrix. So U transpose U is anyway identity matrix. So here you can say sigma V transpose. Is this a symmetric matrix? No, right? I mean, if you take the transpose of it, yes, sigma transpose is anyway sigma, but V transpose, okay, so V transpose will be not V transpose. I mean, it could be V. So basically, if you take transpose of it, it will be sigma V, right? So basically, this need not to be symmetric. It could be symmetric if V is symmetric, okay? So need not to be symmetric, right? Why? Because sigma V transpose, okay, this particular matrix, if you take the transpose of it, it will be sigma transpose V, right? Which is sigma V, okay? It is not exactly equal to sigma V transpose, right? So this need not to be symmetric. What about XV? What about the option B? So what is the option B? Option B is XV. So let me just, paste this question on the next slide and then I can continue from there. Okay. So option B is XV. So in XV, you can say X is nothing but U sigma V transpose and V is anyway V, right? V is anyway V. So it will be U sigma because V transpose V is again identity. Now, is this symmetric? There is no guarantee, right? U sigma transpose, if you do it, then it will be U transpose and then sigma transpose, which is again sigma. So it is not symmetric. It is U transpose sigma, not U sigma. So that's why this is not the answer. This is not the answer. Let's just see option C. Okay. Maybe option C is the answer. Let's just see option C. Probably option C is the answer. Let's just see. Okay. So in option C, they are saying U transpose in place of X, we will be writing U sigma V transpose and then XV. Okay. U transpose XV. So in place of X, I'm writing this. Now if you take the transpose of this, okay. So by the way, first of all, U transpose U is anyway identity. So let me just write it. V transpose V and then V transpose V again identity, so it is sigma. So sigma is anyway symmetric matrix, right? It is a diagonal matrix, okay, and it is a symmetric matrix, okay. Sigma is having the singular values, so it is a symmetric matrix. Is this fine to everyone? Okay, so this is a symmetric matrix, and then similarly you can check option D. Okay, option D will be something like this: X U transpose sigma B. It will be something like this. If you take the transpose of it, it is need not to be symmetric because it will be U transpose sigma. It will be V U sigma V transpose, something like this, right? So it need not to be symmetric. It will be symmetric if obviously if U and V are symmetric matrices. Okay, so only I can say C is the correct answer here. Okay, only in the given options U transpose sigma B, which is eventually actually sigma only, so it is the correct answer here. Okay, so let's just see this question. In this question they are asking that A has three, I mean they're actually asking about the eigenvalues of A, okay, whether it has three distinct eigenvalues or something like this. So what we can do, can we perform row operation or something like this here? No, right? To find out the eigenvalue, you cannot perform row operation first. You first need to find out the determinant of A minus lambda I. You need to make it 0. Okay. So don't do the row operation and then do it, because you have to find out the determinant of this. Now once you form, see. So for example, this is the matrix, right? A minus lambda I equal to 0. This is the matrix which is A minus lambda I equal to 0. Now here if you want to perform row operation or something, you are most welcome. But before that you cannot perform row operation. Okay. Now from here if you find out the lambda, okay, then lambda is coming out to -2 and 4 and A has 3 eigenvalues of multiplicity 1. So basically lambda is coming out to be from here it is lambda equal to 2 and from here lambda equal to -2 and 4. So 3 distinct eigenvalues. So that's why A is the correct answer. Okay. Is this understood to everyone? Okay. Now let's solve this question. How many of you were able to solve this question? This was easy question, to be honest. Okay, I mean maybe you might have found in the examination actually things change, right? Today, I mean after examination I can say it is easy question, but maybe during the examination you might say that okay, it was challenging, because during the exam maybe something doesn't get click. But yeah, I was just making sure that you are comfortable with the questions, because I was not I was not making you to have complexity in reading the questions at least. So I was just making sure that, okay, see, I have given this kind of thing, right? So I was just making sure that, okay, it is clear to you that what I want to ask. So what they are saying, that V and W are the orthogonal subspaces, right? Are the orthogonal subspaces. So let's just say, okay, instead of subspace, I'm just taking two vectors, okay? I mean, one dimensional subspace, okay? Let's suppose this is one dimensional subspace, which is V. This is one dimensional subspace, which is W. Now, what they're saying, if you're projecting some vector on W, okay? If you're first projecting the vector on W, then it will be within the W. Now we are projecting it, okay, to the V. Now you are projecting to the V. So basically it will be anyway 0, right? Because these are the orthogonal. So actually this projection matrix, okay, this itself is 0. Okay. So the projection matrix, which is PV into PW, this itself is 0. Okay. This will be 0. Is this fine to everyone? Okay. So why this will be 0? Because they are just asking for the orthogonal subspaces, right? So first, if you project on this, and then if you try to project on the orthogonal, which is perpendicular to it, then definitely it will be 0. So C is the correct answer here. It was, I will say, easy question, but nice question. I can say, matlab, cute question. Okay. Okay. So actually here I can even say that this projection matrix itself is 0. Okay, so now let's just solve this question. So they are saying that for a system of linear equation Ax equal to B, for the what values of B, the system will have the solution, right? So for what values of beta, basically. So you can just do the Gauss elimination. I mean, first find out the augmented matrix, which is 1 1 0 3 4 1 3 6 beta. Okay, so you can just do the Gauss elimination. Maybe I have done this. Okay, so if you do this, then beta minus 3, because see, for the system to be consistent, so they are asking the system for what values of beta the system is consistent. For the system to be consistent, beta minus 3 also should be 0, because 0 and 0 should match. It should not be 0 and non-zero, right? So beta minus 3 should be 0 and beta should be 3. So I think this was numerical answer type question. Okay, this was NAT question. Okay, this is a numerical answer type, and answer is anyway 3, right? So I hope that was understood to everyone. Let me know if there is any problem in understanding this question. Okay. Now let's see this question. What they are saying: consider the following matrix. An SVD of the following matrix is given. So some complicated SVD is given to you, and then they're just asking a simple thing, which is what is the rank of this matrix, right? So by the way, rank of the matrix is number of non-zero eigenvalues also. Yeah, so I will just tell you regarding the eigenvalues, but I can definitely say regarding the singular values, it is number of non-zero singular values. Right, number of non-zero singular values. So why that is the case, let me quickly prove it. Okay, let me quickly prove it. So maybe we have seen this, okay, but let me just quickly revise it. That if, let's suppose, some matrix is symmetric, okay, I'm not saying this is general matrix. If the matrix is symmetric, then in the symmetric matrix there is something called arithmetic multiplicity and geometric multiplicity. Okay, you might remember, for the symmetric matrix, okay, for symmetric matrix, AM equal to GM. How many of you remember this? I'm just trying to reprove it, which means we have already done in the class. This is a screenshot from the class only. Okay, this is a screenshot of the class. So let's suppose lambda equal to this. Okay, I mean, these are the lambdas for real symmetric matrices. So here, if lambda is repeating, let's suppose 3, 4, 5 times, so there will be 5 linearly independent vectors here, which means nullity will be 5. I can directly say nullity is 5. Okay, and rank will be the rank will be basically, if total number of columns are 9 minus 5, or number of non-zero eigenvalues, you can directly say the rank will be 4. For the symmetric matrices, that is the case. Okay, so actually I wanted to prove for the singular values, okay, not for the eigenvalues. So let's just see for the singular values. But before that, okay, we need to prove that rank of A and rank of A transpose A is actually same. So instead of proving rank, we will prove nullity. Nullity is same and rank will anyway follow, right? If nullity is same, then rank will be same. So nullity in the sense that if some vector is in the null space of A, then it will be in the null space of this, and vice versa also. If that is in the null space of this, and then this is the null space of A. Okay. So if the vector is in null space of A, which means Ax equal to 0, then definitely A transpose, if this thing is itself 0, then A transpose Ax equal to 0. So this is very easy to prove, right? Easy one. Okay. Now let's just prove the other way, that if X is the null space of A transpose A, which means if A transpose Ax equal to 0, I mean X is in the null space of A transpose A, right? So it means, can I say that it is in the null space of A, which means can I say it is Ax equal to 0 also? Let's just see. Okay. So I just need to multiply X transpose both side. Okay. And then it will be Ax transpose into X. So which is Ax is a vector. So basically V transpose V equal to 0. So from here I can say V square equal to 0. From here I can say V is 0 actually. Right. So from here I can say Ax equal to 0. Just multiply by X transpose. I mean, there could be other ways to prove it, but this is the simplest way I can say. So basically, rank of A, this is very important proof. Okay, they can even ask. Okay, in the exam also they can ask the rank of A and rank of A transpose A is actually same. Okay, they can even ask this in the exam. So just take care of this. Okay. Now what they are saying is that that regarding the SVD, right? Regarding the singular values. So rank of A and rank of A transpose is A same. Now we know regarding the singular values that singular values are nothing but eigenvalues of A transpose A, right? These are the eigenvalues of A transpose A. So I can say that non-zero eigenvalues, because A transpose A is anyway symmetric, right? For the symmetric matrix, non-zero eigenvalues and rank is same. So rank is same as non-zero eigenvalues of. So maybe I can go to the next page. So see, rank of A transpose A, right? Since A transpose A is symmetric, so its rank is same as non-zero eigenvalues of A transpose A, which is anyway same as non-zero eigenvalues, or even eigenvalues I can just take from here. So eigenvalues is basically the singular values of, and non-zero eigenvalues are non-zero singular values. I mean zero eigenvalues are zero singular values. So it is a one-to-one mapping, right? There is nothing hard and fast here. So basically, I can say it is non-zero, right? If this is non-zero, then this will be non-zero singular values of A transpose A, right? So so I can say that this rank of A transpose A is nothing but non-zero eigenvalues of A transpose A, which is nothing but non-zero singular values of singular values of A, non-zero singular values of A, right? And then again we have just proved that this rank is also same as rank of A. So all of this is actually equal. Okay, all of these four terms are actually equal. Okay, so these are the four quantities that I'm writing here. We have already proved this. We already know this, right? I mean, these things, this is obvious. We already know this. We just need to prove this. Okay, so basically there are two kind of proof which involving. So one is this, right? For the symmetric matrix, this is true, right? For the symmetric matrix, this is true. This we have just proved, right? This we have just proved. This we just know. So we know that, okay, all of these four quantities are actually equal, right? So rank of A is nothing but non-zero singular values. So if they are giving something like this, okay, anyway, like proof is not necessary, but I have just proved it again and again. Okay, so if they are giving you some matrix A, right, and the singular value decomposition is given to you, they're asking you the rank, then you can say, okay, non-zero singular values is the answer, right? So rank of A is non-zero singular values. Is this fine to everyone? Okay. So let's solve this question. In this question, they are saying that we have given some fx, sorry, not fx, x by z w. Okay, I mean this is a multivariate function. They're asking the stationary point, which means they're asking you to the point where del is 0. So see, since it was AIMT1, that is why I did not want to make it too complicated. Maybe in the examination they will not give you, okay, they will not give you this hint. This was the kind of hint that you need to make the grad 0. Okay, this was the hint. Okay, so maybe in the examination they will not say I. Okay, maybe in the gate, maybe they can write, maybe they cannot write. Okay, so I have given you in few questions, I have given you little bit of hint so that you can at least attempt that question. I want you to solve that question. I don't want you to feel like that, okay, you can't solve the question just because you don't remember the definition of a stationary point. So that's why I have given the definition itself here. Okay, so you can find out the grad. Okay, maybe it is EG. So it will be with respect to X, with respect to Y, with respect to Z, and with respect to W, right? You need to find out it. So if you find out it, it will be with respect to X, it is basically 2X, it is 2W, it is minus 2Y plus 3Y square plus Z, and then this is Y plus 2Z. Okay. If you make it 0, then X and W is anyway 0, right? And then if you put at least something here. Okay, so okay, using these two equations, if you just put y equal to minus 2z, okay, and then if you just solve using these two equations, you will be getting something like this. Within the z you will be getting, because these two equations are by and z only, right? So see, x and w are anyway 0, right? You can find out y and z using these two equations. So if you find out it, then I think you will be getting something like this. So you will be getting two values of z. Okay, two values of z equal to 0 and z equal to minus 5 by 12. For z equal to 0, there's just I mean only one value of y. There's only one value of y. Okay, here we are getting one values. So basically y equal to 0. Okay, this is one pair. Okay, anyway x equal to 0, y w equal to 0 will anyway come in, right? And similarly z equal to minus 5 by 12 and y equal to 10 by 12. This is another pair. Okay, so anyway this particular thing will come here also. So these are the 2 points. Okay, two stationary points. One is this, which is x equal to 0, w equal to 0, and this, and another one is this. So these are the two stationary points. Is this understood to everyone? Yes, we just need to do f dash x equal to 0, or maybe grad equal to 0, right? Okay, so I hope that is understood. If there is any issue, you can just let me know. Okay, now this was a question related to limit, right? So we know that limit x tends to 0, sin x upon x is 1. So here see, this thing also go to 0 and this thing also go to 0, and these two things should be same, then only it is 1, right? Now if I'm writing sin 4x upon x, let's suppose if I ask you this limit, can this be 1? See, this is going to 0, this is going to 0, but are these same? These has to be same. X means this has to be same. So these are not same, so that's why it is not 1. But if you multiply by 4 up and down, right, then this thing is actually 1. So ultimately this is 4. Okay, so I can say limit sin 4x upon x, it is x tends to 0, it is actually 4. If this is understood, then you can solve this question, right? You can solve this question easily. So what you need to do in this particular question, right? So I think this was a 1 mark question, so that's why it was easy question only. So let me just tell you what you need to do. So see here, you can just do one thing. You can write sin 4x upon 4x, just see, okay, that can you write something like this? I mean, what you need to multiply and not, we will just see. So I think 12 we need to multiply on the numerator, right? So this is 1, and 12 is the final answer, right? This is 1. So 1 into 1 equal 1 into 1 into 12 is equal to 12, right? So 12 is the final answer. That was the easy question only. Let me know if you have understood this particular explanation. Okay, now let's just do the next question. Yeah, this was little good question. I can say it was a good question. So here they are saying that we have given you, okay, some binary random variables, which means that either it can be 0 or 1, okay, taking the value either 0 or 1 with equal probability, right? So maybe I can make the table that it could be 0, 1, 0, something like this, right? Okay, then x plus y will be either 0, either 1 or 1 or 2. Okay, x plus y is not binary random variable. It is again a random variable, which is a different, right? It is not a binary one, because I mean it is even taking the value of 2. Okay, so anyway, so what they are saying, that given that x plus y is 1, so given that we are only talking about this particular reduced sample space, okay, so since it is a conditional probability, right, so we are only talking about this. So basically, see, I can say, I can say, if I have to ask, what is the probability, what is the probability, if someone says, okay, what is the probability of x plus y being, let's suppose, being 0, can you tell me? Only see, everything is a 1 by 4 probability, because this is 1 by 2, this is 1 by 2, so it will be 1 by 2 into 1 by 4. This particular row has 1 by 4 probability, 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 so it is 1 by 4. Probability of x plus y being 1, what is this probability? Being 1. Since these two are summing up to be 1, I mean these two are giving you 1, so that is why this probability is actually 1 by 2. I mean 1 by 4 plus 1 by 4, which is 1 by 2. Okay, let me know if that is understood. Now probability of, now the probability of x plus y equal to 2, it is 1 by 4, right? Okay, now what they're asking is that, given that, okay, that you have already got it, so there are multiple ways to solve it. I'm solving it using the reduced domain, I mean reduced sample space. I can just show you using the other formula also, but let's just do it using the reduced sample space. Okay, so they have given this, they have already given this, that okay, this is 1, right? So that's why I have removed other things. But are these probabilities now 1 by 4, 1 by 4? No, right? You have to actually, again, see, to start with, it was uniform distribution, right? So now you have to again do the uniform distribution between the rows. Okay, so which means this probability will not be 1 by 4 in the reduced sample space, it is 1 by 2, 1 by 2. Now they're asking, okay, I mean, given this is 1, what is the probability that x is 0? So what is the probability? So x is only 0 in one of the case. So this is 1 by 2. I mean, probability of x being 0, given that x plus y is 1, this is 1 by 2. Okay, using this reduced sample space, you can do this. Maybe little bit you remember from the class. If you don't remember from the class, then we can do this using the formula also. Okay, now let's just do this using the formula. Okay, so what is the formula? Let's just see. Let's just using the formula. See, what we need to find out. We need to find out probability of x being 0, given that x plus y is 1. Okay, given that x plus y is 1. Is this okay to everyone? We need to find out this, right? Now what you can do, you can use the formula x equal to 0, comma x plus y is 1, right, divided by probability of x plus y is 1. So what is the probability of x plus y is 1? I think this is anyway 1 by 2, because we have seen this, right? This is 1 by 2. What is this probability? This means x is 0 and y is 1. So basically this means x is 0. I mean, if you put it, so y will be 1, right? So x is 0, y is 1. This is 1 by 4 probability, right? So it is like 1 by 4 divided by 1 by 2, which is 2 by 1, which is again 1 by 2, right? This is again 1 by 2. So this is method 2. This is method 2. Is this fine to you? Is this fine to you? Okay. So let me know if that is okay to everyone. Great. Now let's just see the next questions. So now let's just see this question. What they are saying? The random variable x has the following probability distribution function, PDF, right? So they're asking you to determine f3 minus f2, where fx is the CDF function, cumulative distributive function. So what is the CDF? What is f3? f3 is nothing but probability of x is less than or equal to 3, right? What is f2? f2 is nothing but probability of x less than or equal to. Okay. So this is f3, this is f2. Now they're asking you f3 minus f2. So which means x less than or equal to 3 and xc. See, this is, let's suppose this is 3, this is 2, right? So the probability x less than or equal to 3, the probability of less than or equal to 2. You need to subtract these two probabilities, which means basically if you subtract one probability from another, this is less than or equal to 3, this is less than or equal to 2. Okay, 3 and 2. So it will be probability of x being 2 to 3. Right? I mean, you just need to integrate this between 2 to 3. 1 by 6 x. Right? So you just need to integrate between 2 to 3. Okay. So that was an easy question only. Is this fine to everyone? Okay. Now let's see this question. What this question is asking. The graph below has the probability distribution function. So find out the value of the constant c. Right? So they are asking you that what is this value c. So basically, since this is PDF, now the integration over all the minus infinity to infinity, it should be 1. So basically, anyway, this is integration is 0, this is 0. So we just need to integrate, or we just need to find out the area of this particular section, right? So what is the area of this? 1 by 2 into base into height, right? So base is anyway 1, height is c. So area of this is c by 2. And then you can just divide this also. So area of this is square, right? So 1 into c, this is c. Again, this is 1 by 2 into this height is 1 and base is 2c. So it is c. Right? So I think this is 2c plus c by 2. So which is 5c by 2. Okay. So 5c by 2 should be 1. In fact, c should be 2 by 5. Right? C should be 2 by 5. Is this okay to everyone? Okay. So I think B was the correct answer here. Let me know if there was any difficulty in solving this question. Right. Okay. Now let's see this. What they're asking. 3 engineers, Jen, Pat, and Rory, are processing work orders. The time it takes for each of this to complete one work is as follows, right? So Jen takes on an average of 3 hours. I mean, they have given that, okay, it is taking 3 hours, 1 hour and 4 hours. Now they are saying that due to their speeds, Pat process 50% of the work orders. So basically it does the 50% of the work. Jen and Ronnie does the 25% of the works. Now on average, how much time? Okay, mean time, on average, how much mean time it will take for them? So it is kind of conditional expectation or the total expectation kind of question. Okay, which means that you can say the total time it will take is basically 1 by 2 time is done by Pat, right? I mean 1 by 2 of the work is done by Pat. So Pat is taking anyway 1 hour. So it is Pat plus 1 by 4 is done by Jan. So he is taking 3 hours. This is 1 by 4 plus 1 by 4 is taken by 1 by 4 is taken by Rory. So Rory is anyway taking 4 hours, right? So you can just solve this particular equation. Maybe I have, okay, solution. So 9 by 4 is the correct answer here. Okay, is this understood? Okay. Now let's see this question. In this question, they're asking which of the following not a convex function, right? See, this is a sigmoid function. The sigmoid function, is this a convex function? Sigmoid function looks like this. So definitely convex basically means that you always have, this is a convex, right? You have to have this, I mean the line which is joining 2 points should be the above the curve. So basically it is not always above the curve. I mean sometimes it is above, sometimes it is below. So in fact I can say if it is less than 0 then it is above. If it is greater than 0 then it is below, right? So till this point I can say it is convex, right? Till this point it is convex, but after this is actually concave. So overall this is not a convex function, right? I mean, this sigmoid function is not a convex function. 3x will be just a linear line. So yes, it is basically the convex function, because line joining any 2 points will be the above or on it, right? I mean, it is not a strict convex. There's a definition, something called a strict convex. It is not a strict convex, right? But it is a convex function. Okay, strict convex means this should be strictly above that, right? But it is actually on this, but no, that's fine, right? So it is definitely the convex function. What about x square? X square looks like this. This is a convex function. ReLU is looking like this. Okay, initially it is 0, when otherwise it is like this, right? So it is basically, anyway, it is in some wall shape or something, right? Bowl shape. So basically if you join two lines, it will be like this, above the curve. So that's why this is also the convex, right? This is convex, this is convex, this is convex, but this is not convex. So they're asking about the not convex. So you can say this is not convex. The option A is not convex. Is this fine to everyone? Okay. Now let's see this question. What they're saying. Which of the following is are true? So this is a good question. Okay. So it is asking you that if these are disjoint, then are they independent? See, let's suppose these are completely disjoint events. Let's suppose this is A, this is B, right? This is A, this is B. Now, if I know that B has happened, or maybe A has happened, whatever, right? Let's suppose if I know that A has happened, then do I know that what is the probability of B? Actually, I know this, right? It is actually 0. I mean, B cannot happen. So if they are disjoint, then they are extremely dependent, because they are not independent. I mean, if you know that okay, A has happened, so A has happened is actually impacting the probability of B. It is not same as probability of B, right? It is actually 0. So if they are disjoint, then we have seen this. They're very much dependent, right? They're not independent. They're very much dependent. Okay. So that's why it is false. What about this? See, in the formula, probability of B will come here, right? But they are writing something like this. So that's why this is also false. What about this? Probability of A union B and probability of A intersection B. Let's just check it. A union B. See, if this is A, this is B, right? So A union B is basically saying the whole probability. Obviously, it will be greater than or equal to this only single probability. You can just do it with the Venn diagram, right? So if you are saying A union B is actually the whole probability, right? Whole probability. And A is just this probability. Obviously, it will be greater. I mean, the whole probability will be greater than or equal to. Okay. So yes, that is true. What about this? What about this particular question? So they are saying A intersection B is this, right? A intersection B is actually this. So they are saying A is greater. Yes, obviously A has extra part, right? So probability of A is anyway greater than greater. So that's why this will be also true. This is true. This is true. You can just do this with the Venn diagram. Okay, with the Venn diagram you can do this question. Okay, so someone is asking how y equal to 3x is convex. Y equal to 3x is convex. See, y equal to 3x will be some line, something like this, right? Let's suppose this is, let's suppose this is y equal to 3x, right? Now, what is a convex function? You should be having, I mean, geometrically, I'm telling you, there is a mathematical definition also. You can just actually differentiate it 2 times. It should be greater than or equal to 0, right? You can just differentiate it 2 times. So it is 3 and then it is 0. Y double dash is 0. Since it is greater than or equal to 0, so you can say it is convex. Directly, you can see it is convex, right? So, but yeah, you can even do it geometrically. That if you draw the line in between, 2 points, then it is either on the curve or above it. I mean, it is never below it, right? It should not be below it. So it is not the below, right? So that's why it is a convex function. Or maybe you can differentiate it 2 times and then see if it is greater than or equal to 0. Okay, to check the convexity, right? Okay, so now let's just go to the next question. Yeah, this was a good question related to related to the concept that you should be knowing the how the decomposition error should work, right? So if you remember that this is mean square error is bias square plus variance plus this is called irreducible error, right? So sigma is irreducible error. Now they're asking the same thing. What is the irreducible error? This is sigma square only, which means the variance of basically the sigma square is the variance of the noise, right? So 4 is the correct answer here. You just need to know that okay, there is some this kind of decomposition exists. Okay. So basically we have proved this also. Okay, we proved this in the class, in the bias variance class, right? That bias square plus variance, and then there is some constant. Okay, this is a constant. But this is sigma square. Sigma square means the variance of noise. I mean, this is because of the noise. Okay, because of the irreducible error or because of the noise it is coming. This is because of the noise, which is not in our control. Noise and data. Okay, which is not in control of the machine learning models. Okay, not in. I mean, the data collection is not in control of machine learning models. Okay. So if you know this, then you know the sigma square is 4. So what is the irreducible error? Irreducible error and sigma square is actually same. Okay, this is called irreducible error. In this particular formula, this is called irreducible error. This is well standard formula. So this question I have taken from some university. Maybe I can even tell you which university I have taken. Yeah, University of Washington. Okay, I've taken this question from University of Washington. Okay. So this is actually the well standard formula of this, which we have already proved in the class. But yeah, we do not need to prove it. We do not need to even remember the proof or something like this. But I'm just telling you that there is a proof that exists, right? And this is an easy question. Okay, once you know this formula, you know that okay, irreducible error is just sigma square, right? Which is 4. Now let's see this question. This question is related to calculus, in the sense that you should be knowing what are the necessary and sufficient condition for the minima. Okay, this is a basic requirement. Okay, these things are basics that you must know for any machine learning course. Okay, you must know. Okay, that see, given whether it is linear regression, logistic regression, we will be doing all of this in the multi-dimension, right? We will not be doing linear regression with just one variable x. We will be having multiple features, x1, x2, something like this, right? So you should be knowing that okay, what are the basics of this multi-dimensional calculus. This is must know. Without this machine learning you cannot even attend, or you cannot even do even a single algorithm of supervised machine learning, at least, right? If you don't know these things, this is basics, right? This is basics of optimization. Okay, we have done this in the class. Okay, in class we have seen this. So this is the slides from the class. So we know that x star is the local minima if and only if. So it is a basically if I'm going for the second order in the sense that if I'm going till the Hessian, then I can say that if and only. I mean second order is basically a sufficient condition. Okay. Uh, Sorry, this spelling is wrong somehow. Okay, but anyway, that's fine. So second order is a sufficient condition in the sense that using the first order, you just have the necessary condition. I mean, for the minima or maxima, it should be 0. But given that it is 0, you cannot say anything. You have to go to the second order condition. So the Hessian should be strictly greater than, sorry, Hessian should be PD. PD in the sense that this particular thing, right, should be strictly greater than 0. So Hessian should be PD, positive definite. Okay, so they are saying for the minima, Hessian should be negative definite. So that's why it is false. This statement is false. Because Hessian should be positive definite, not the negative definite. Okay. So let me know if that is okay to everyone. Okay. So someone is asking, Nikhil is asking, sir, can you tell the Hessian matrix, these things? Yeah, I'm Hessian is the double differentiation only. Okay, so Hessian, see, for any f, let's suppose this is xy. Okay, grad is nothing but something like this: grad f upon grad x, grad f upon grad y, right? Hessian is the double differentiation of this, which is grad f upon grad x, grad x. Okay, I mean, you need to take the double differentiation. Okay, and then double differentiation with respect to y, xy. This is double differentiation with respect to, again, xy. This is double differentiation 2 times y, right? This is the Hessian matrix. Okay, it should be positive definite for minima. This is a sufficient condition. Okay, sufficient means if I have this, then it will definitely be minima. This is sufficient. Okay, should be strictly greater than 0. Strictly greater than means positive definite. Okay, this is the sufficient condition for the optimality. Okay, this is not sufficient, this is only necessary. I mean, first order conditions cannot even give you the sufficient conditions. Okay, D is a vector. This is the positive definite. D is a vector. This is the definition of the positive definite. Okay, for any vector, you can take this vector as x, but since x was taken here, so D is a vector. Okay, so what is the definition of positive definite? Positive definite is in the syllabus of linear algebra. Okay, in linear algebra, the positive definite is, I think it is even mentioned as an official part of syllabus. Okay, so if you check official syllabus, most probably should be mentioned, otherwise like it is anyway part of the linear algebra. Okay, so I think that is not explicitly mentioned. Let me check the syllabus. Yes, explicitly it is not mentioned. Positive definite and negative definite matrices. Okay, so positive definite matrix is basically matrix A. It is called positive definite if for any x this is greater than 0. For any x. Okay, so ax is anyway a vector, and this whole thing is a scalar, right? So for any x, if this is greater than 0, this is called positive definite matrices. Okay, yes. So basically, I mean, even if you check any standard lecture, maybe let's suppose if I just tell you lectures of Gilbert string. Okay, I mean, this is a standard thing in linear algebra. This has to be studied. Okay, so if I just tell you the lecture series of Gilbert string, then probably I will just, let me just show you. Yes, so it is here. Let me just paste the screenshot. So I mean, if you check any standard lecture series, the positive definite, negative definite matrices will anyway there. Okay, so this is a, I mean, there are multiple lecture series, I think, of Gilbert Stein. So I'm just telling you one of that. So this is, I mean, Gilbert Stein, you might know him, right? He is a legend. So he's a living legend. So one of the lecture, he's talking about the positive definite and semi-definite matrices, right? So positive definite is actually part of the linear algebra, and we have seen this in the linear algebra, I think, right? I mean, I've taken this positive definite lecture. Yes, in the linear algebra only I've taken. Okay, okay. So we have already studied this. Maybe you will see this in our Go classes YouTube channel also. So you can see in our YouTube channel also. Let me just, yes, in our YouTube channel you can see this lecture. Let me just paste that particular screenshot. Okay, if you are not familiar about this positive definite and these things, you can just go through these lectures. Okay, this is available at YouTube. Go classes for gateta. Okay, you can just check this lecture. So Ganesh is asking how E is variance is irreducible. So we have proved it. Ganesh, don't worry about the proof. Okay, just there's a, the error can be decomposed in the bias and variance form. Bias variance decomposition is very important, and this is a part of syllabus. Even it is mentioned in the official syllabus. If you check the official syllabus, I don't need to again and again prove it, but yeah, since gate DA is new, so some people might think that okay, this is out of syllabus question or something like that. But don't worry, we will obviously not teach anything which is out of syllabus. We will not ask anything in the test series also which is out of syllabus, right? So if you check this bias variance trade-off, okay, bias variance trade-off is there in the official syllabus also. So this is bias variance trade-off formula in the sense that the error can be decomposed into bias variance and some constant. That constant is called irreducible error, and which is the variance of actually the error. Okay, the variance of the noise. Okay. Now let's just continue. So that is why actually in this case, if I solve this question, where is the question? Yeah, if I solve this question, this is false, but this is true. Okay, this is true. The gradient should be 0, and it is just a necessary condition. Now suppose they say this is sufficient condition. Suppose this is sufficient condition, then in that case this will be false, right? This is just using the gradient you cannot even give the sufficient condition. Using the gradient you can only say the necessary condition. If you have to give the sufficient condition, Hessian should come into the picture. Okay, and it should be positive definite for the minima, negative definite for the maxima, right? Okay. Now let's solve this question. This was nice and interesting question, I can say. Okay, this was nice and interesting question. So what they are saying in this question is that the graph of f dash is given. Okay, remember it is not a graph of fx. This is a graph of f dash, right? Now they are saying that which of those this is true. Okay, so maybe I can just maybe I can just do one thing, zoom it out. Okay, and let me just paste this graph also side by side. Okay, so now they are saying which of this is true. F has local minimum. See, this is f dash x graph, by the way. So it will be positive. So don't worry about the curve here. It will be up and down or anything. But yeah, f dash is positive. Okay, till 3 it is positive. So you can say f dash is positive, right? It is positive, 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 positive. Maybe it is going down f dash or going up, doesn't matter. But it is at least positive. F dash is positive here, and it is negative here. So f dash is positive means function is increasing. This is, let's suppose, f graph. Okay, now I'm plotting f graph. This is f. Function is increasing, and then at 3, okay, till 3 it is increasing basically. At 3 it might be start decreasing because the f dash is negative. So this is the sign of f dash. Okay, this is f dash x sign. So this is the plot of fx. This is a plot of f dash x. Is this okay to everyone? See, we don't need the plot of f dash x to solve this particular a, or to solve this particular first point. We don't need the plot, we just need the sign. Okay, before 3 it is positive, after 3 it is negative. It means it is a local maxima actually. Okay, this is the maxima point, so that's why it is false. Okay, here we have not used the plot entirely, we have just used the plus minus signs. Okay, maybe in this particular question maybe we can use it, but let's just see. Okay, let's just first solve this third point. They are saying f is increasing. They are asking about increasing in this 0 to 3 interval. Yes, it is increasing, right? It is increasing because it is positive. Again, we are not using the plot. Okay, how it is looking? I'm just using the sign. So to solve 1 and 3, we are not using the plot. We are just using the sign. Yes, it is increasing. This is true. Is this okay to everyone? Till now, it is fine. Till now, it is fine. Yes, Nikhil. Actually, it was much needed question. Honestly, I mean, these things are there to make you learn, because this is, the basic question, I can say. Okay, you must know this because this is a basic optimization thing, right? I mean, you should know how to find the minima or maxima given the, let's suppose there is just some linear regression you are doing, and you are writing some function, loss function, right? Suppose you are writing fx, okay, y minus y cap square, okay, something like this, right? Now this by or y cap, maybe it could be multivariate. Obviously you will be having w1 x1 plus w2 x2, something like this, right? For the y cap, so you should be knowing for multivariate functions how to know, I mean, how to, at least theoretically you should be knowing that, okay, how to find the maxima and minima, right? So this is much needed, and we will be putting this kind of, I mean, questions based on this, at least one question in every AIMT, so that it will be, very much clear to you guys. We will be putting these kind of questions in every AIMT. Okay, yes, this is a very good question, mixture of multiple concepts. Okay, so is this understood to everyone? That for this f is increasing on the interval 0 to 3. For this also, I'm not using the plot, I'm just using the sign. It is positive, it means it is increasing. Okay, it is from positive to negative, it means it is maxima, not minima. Okay, so this is true. Now let's just see, for concave of, actually we need to use the sign, right? Sorry, we need to use the plot. Why? Because see, maybe you have seen this lecture. This is already available in our YouTube channel. Okay, probably you might have seen this lecture. So they are saying introduction to maximum minima, the first derivative test. Okay, so they are saying that uh, if f dash x is greater than 0, then function is concave up. So basically for the concave up, okay, if f double dash x is greater than 0, then it is concave up. Okay, which means if that is the case, then it will look like this. Okay, so this is a plot of fx. Now what about f double dash x? See, if I just have plot of fx, something like this. Now f double dash x should be greater than 0. If f double dash x is greater than 0, then fx will look like this at that particular moment. I mean, it is not that entirely it will look like this. Okay, we have seen these things in this lecture already. Okay, if you have not seen, you can just see this lecture that is available on our YouTube channel. So see, what I'm saying here is that at that particular, see, maybe fx could be something like this, but at that particular moment, okay, at that particular x, at that particular moment, it is taking the shape of concave up. Okay, later on it can do anything, but at that particular moment it is concave up, right? So anyway, if f dash x is greater than 0, it is concave up. Now here also we can see, let's suppose they say f double dash x is greater than 0, then we know it is concave up, but either this part of concave up or this part of concave up, which means it is decreasing or increasing, that will be given by f double dash x. So basically, if for this part it is decreasing, which means f dash x is less than 0, it is increasing, which means f dash x is greater than 0. So basically in short, I can say, okay, maybe you have already studied probably these things, but still I'm just quickly repeating. If someone give you these two quantities, f double dash x is greater than 0, let's suppose, okay, and if someone give you these two quantities and f dash x is, let's suppose, also greater than 0, it means it is concave up and it is increasing also. So it is concave up and increasing also. So basically the function will look like this. Okay, so function will be taking this kind of shape at that particular moment. Okay, if someone is saying f double dash x is greater than 0 and f dash x is less than 0, which means it is concave up but it is decreasing, concave up but it is decreasing, then it means at that particular moment the function will be taking this kind of shape. Okay, concave up but it is decreasing. Okay, is this okay to everyone? Now here in this question they are saying f is concave up. Okay, they are not asking increasing, decreasing between 1 to interval, which is fine, but I told you multiple concepts, right? No, they're just asking concave up. So in between 1 to 2 is the f dash x, also f double dash x. Okay, you need to check f double dash x, okay, for the concave up in between 1 to 2, in between 1 to 2, right? So something like this. F double dash x means whether f dash x is increasing or not. So f dash x is actually increasing, right? So f double dash x is actually greater than 0. So yes, it is greater than 0. F double dash x is actually greater than 0. You need to infer this f double dash x quantity from this graph. So between 1 to 2, yes, f dash x is increasing, so f double dash x is greater than 0. We need to actually know about the f double dash x to determine the concave up or concave down, right? So yes, this is actually true. So I think 2 and 3 are true. So C is the correct answer here. 2 and 3 are true. Okay, that was really a good question. How many of you were able to solve this question? That was really a nice question. Okay, so C is the correct answer here. Isn't it? How many of you found this question to be good? Let me know. How many of you found this question to be good? Yes, right. Okay. So why one is false? One is saying f has local minimum at x equal to 3. Let me just tell you why one is false. One is saying f has local minimum at x equal to 3. It is going, see, just see the sign of f dash x. It is going, don't worry about the curve, just see the sign. Okay, it is going, see, it is positive, f dash x is positive, which means function is increasing and then decreasing. It is negative later on. So it is actually maxima, not the minima. Okay, they are saying the minima. It is actually the maxima, right? Just see the sign of f dash x. So which means fx will be increasing first and then decreasing. Okay, so it was really a good question. Let me know if that is understood to everyone. Okay, okay. Now, let's just see the next question. Okay, so I hope you understood this question. It was really a good one. So let's see this question. This question is saying that a program selects a random integer x, right? And then they are saying it based on this random bit. Okay, so the bit can be either 0 or it can be 1, right? If it is 0, then x is taken. Okay, x is taken uniformly from 0, 0 1 to 3, right? If it is 1, then x is taken from 0, minus 1, minus 2, minus 3, minus 4, minus 5, minus 6, minus 7. Okay, something like this, right? I mean, if x is 0, if the bit, okay, bit you are selecting, if it is 0, then x is something like this, x belong to something like this. Now they are saying what is the probability that x being 1? Okay, so first, what is the probability of taking 0? And then what is the probability? See, first, what is the probability that bit is 0? And what is the probability of mod x is 1 given that bit is 0, right? Plus, this is, I think, easy question. How many of you were able to solve this question? Okay, bit is 1. So what is the probability that bit is 0? So you can solve this question easily like this. What is the probability that bit is 0? 1 by 2 into, if bit is 0, then in that case, what is the probability? It will be, mod 1 will be 1. So I think 1 by 4 probability, right? 1 by 4 here. Because x belongs to 0, 1, 2, 3 here. So 1 by 3, 1 by 4, because it is equal probability, right? Plus bit 1 is this. What is the probability mod x will be 1? 1 by 8. Why? Because here x belongs to minus 0 to minus 7, right? So here only one of the possibilities giving you mod 1 is 1, mod x is 1, right? This is 1 by 8. So it is actually 1 by 8 plus 1 by 16, which is 2 by 16, which is 3 by 16, right? It is easy question only. How many of you were able to solve this question? Okay, so Advut is saying that he has already watched the lecture regarding the positive definite matrix. I think no, concave up, concave down. Okay, you're talking about this lecture, right? Okay, great. So 3 by 16 is the answer, right? So it was just a total probability or Bayes theorem kind of question. So now let's see this question. In this question, what they're saying, distance between two binary strings are defined something like this. That, I mean, this is called Hamming distance, by the way. Okay, so this distance is 2. Okay, number of bits in which they are differing. Okay, suppose we randomly pick two binary strings C1 and C2 of length 100. Okay, so length, this is the, I mean, in the decimal, obviously, right? The length is 100. Independently, okay, so we are selecting, okay, so we are basically having two strings C1 and C2 of length 100. And independently, we will be selecting 0 or 1 here, 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 something like that, 0 1 0 1 0 1 0 1 0 1, like this, right? Now they are saying that let xi be the indicator variable such that xi equal to 1 if C1 and C2 differ in some position. I mean, if this is 1, this is 0, so x1 will be 1. Let's suppose this is x3, this is, let's suppose, 0 and 0. Then what is the value of x3? X3 will be 0. I mean, if they're not differing, then the particular random variable for this particular position will be 0. If they're differing, then the particular random variable for that particular position will be 1. Now they're saying, if you sum all these distances, I mean all these random variables, so it will be total distance basically, right? So this is the total distance. Now what is the expected total distance, right? So basically we need to find out what is the expectation of x1 plus x2 plus x100, right? So probably you can relate it. This x is basically x1 or xi is binary random variable, or you can call it Bernoulli random variable also, right? This is Bernoulli. Okay, this is Bernoulli random variable. So anyway, like, it's not needed for this question, but I'm just saying it, right? So this is same as, first of all, can you tell me what is the expectation of x1? I mean, this is same as expectation of x1 plus expectation of x2 till expectation of 100. What is the expectation of just one quantity here? This will be, you will say x1 is basically either 1 or 0. If both are matching, if both bit are same, okay, otherwise it is not same. So what is the probability of not same? I mean, it will be equal probabilities, right? Because if either both will be 0 0 1 1, this will be 1 by 2 probability, or with 0 1 1 0, this is again 1 by 2 probability. So basically this is with the 1 by 2 probability, right? So 1 by 2 probability will be there for 1, and 1 by 2 probability will be there for 0, right? So this is expectation of x1, which is just 1 by 2. And then there are 100 of it. So you will say that, okay, this is 1 by 2 into 100, which is 50. Okay, so 50 is the correct answer here, right? Or maybe if you want, you can solve this particular question using the binomial random variable. I mean, summation of Bernoulli random variable is actually binomial random variable, which is n into p, right? N is the number of random variables that you are summing up, which is 100, or number of trials, and the probability of success or probability of this, which is 1 by 2, right? So basically this is Bernoulli random variable, x1 is Bernoulli random variable, but the summation, if you sum this up, then this is called binomial random variable. Binomial random variable has the simple formula n into p. N is the number of Bernoulli random variable that you are summing up, or number of trials, okay, which is 100, into probability of one of the random variable, okay, of success, probability of success, or probability of one of the trial to be success, which means x1 or x2 or anything to be 1, probability of x1 to be 1, which is 1 by 2, right? So 50 is the correct answer here. Now even they could have even asked you the variance of this, distance. So what is the variance? Do anyone remember the formula of variance? N into p into 1 minus p, right? This is the formula of variance for the binomial random variable. N is 100 here, into 1 by 2 into 1 by 2, which is 25 is the answer. They could have even asked the variance also. Okay, they could have even asked the variance also. Is this fine to everyone? Okay, so see, here in this question they have defined the random variables and all. Okay, maybe some of you might have found this question little tricky because they have defined the random variables, but actually this original question was this, which I have defined the random variables and all. But if they ask the original question, okay, then actually you should be comfortable with both of the ideas, in the sense that even if they define the random variable, then also you should be comfortable. If they don't define the random variable, then you can say that, okay, see, this is they have just defined the distance, but now you just see this. They are saying pick a random binary string of length 100 each bit is equally likely to be 0 1, that x is the ones in this string. Okay, okay, this was actually original question which I just little bit manipulated. So here they are asking expectation variance, but yeah, that question and this question is almost same. Okay, so they are saying that if you are taking 1 and 0, what is the number of ones? Okay, they are just asking the number of ones, but yeah, this question was the original question, but I have just tried something else in that question, and I am asking you something else. Okay, but yeah, almost similar. But what I'm trying to say, that they can define random variable, or they can just say something like this. Okay, they do not need to do this. They can just say, suppose we are picking independently, and then they can directly write. Okay, they can directly write one line here. What is the expected distance between C1 and C2? Just like this. Okay, they do not need to do all of this. Okay, they do not need to do all of this. They can just escape this. Okay, they can directly give you something like this. So because that's not needed, right? That's not even needed. They can just say this. What is the expected distance? Okay, the expected value of the distance. It was just to help you. Okay, I mean, it was just to help you that you can just relate it with the random variable. But suppose they do not give you something like this, then are you comfortable with this question even then? Okay, that is my question. You should be comfortable. It was AIMT 1. That is the reason I have given you, some hints here and there. But in AIMT 2 or AIMT 3s, I might not give you these hints. Okay, maybe you just have to solve without the hints. Okay, this is the hint, because I can call it the hint because here you can apply the expectation formula, expectation of x1. Then you can think individually regarding the expectation of x1, right? But they do not need to give all of this. You need to formulate it. Okay, you need to check it. Okay, you need to define this by yourself. You may have to define this by yourself in the exam itself. Okay, for each of this bit, let's just define a random variable. It should be clicking. If it is clicking, then you can solve this question even if they do not give this kind of information. Okay, so we will be having more questions in next AIMTs where I might not give you these kind of information. I will not give this information. Okay, I will not map it to random variable. The mapping has to be done by yourself. Okay, this is just a mapping, right? This should be done by yourself. If that is done by yourself, then you can even solve complicated questions, something like this, right? But yeah, this question is anyway, this question is quite good. But what I'm saying, they can escape this. Okay, all of this mapping to the random variable, the mapping or the defining the random variable. If you do this, it will be better. Okay, I mean, if you don't do this, that's fine. But if you can do this, it will be little better. Okay, I mean, it will be just helpful probably to solve 1 or 2 questions in the exam if you can map it with the random variable also. Yeah, so this was actually, to be honest, I found this question to be good, right? This is little unique question. I mean, they are saying if bi is 0, then x is following some different Bernoulli distribution. If bi is 1, then x is following some different Bernoulli distribution. Okay, so this was unique in this sense, and this was a good question. They're just asking you the joint distribution, which is easy, I think. Okay, I think, see, probably let's just find out one. Yeah. Okay, let's just find out this quantity, because this quantity is differing in all of the options. Okay, maybe I can just find out this quantity. So what is this quantity? This is probability of y being 1 into probability of x being 1, given that y being 1. So what is the probability of y being 1? See, y is following Bernoulli random variable. So this is the probability of y being 1, right? 1 by 3. It is 1 by 3 into, what is the probability of y being 1? If given that y is 1, what is the probability of x being 1? This is 4 by 5. It's easily given here. 4 by 5. So 4 by 15, right? So 4 by 15 is this probability. And I think only one of the option is matching with the 4 by 15. So B is the answer. Okay. I mean, you don't need to do all of this. But yeah, that was, something easy or nice question, I can say. It was easy, but still, I can say it was, cute question. Short and sweet. Right? Or maybe you can find out all the other in the similar way. But yeah, one of this we can find out, which is 4 by 15. Okay. Now let's solve this question. In this question, they're asking about the expectation of x and expectation of x square, right? So expectation of x is basically 0 to, oh sorry, minus infinity to infinity. I mean, for all the possible values of x into fx, right? Dx. Now, using the Lotus formula or law of unconscious formula, you can say the expectation of x square. You do not need to find out the CDF of x square. So you can say expectation of x square also, right? So you can do this question using find out the expectation of x. I mean, you just need to integrate this and this, right? So if you do this, 2 by 3 and 1 by 2 is the answer. So these kind of questions are very relevant to gate DA. In gate DA also, they will be asking similar kinds of things of questions. I mean, they will be giving you some CDF, oh sorry, some PDF. They might ask you expectation, or they might ask you conditional expectation. Okay, so for this question, I'm not asking the conditional expectation, but I will definitely ask a conditional expectation in the next AIMT. Okay, so in the next AIMT, I will be asking you the conditional expectation, and PDF will be given for the continuous random variable. Okay, I will be asking the conditional expectation. Okay, now let's solve this question. In this question, they are saying the covariance. They are, see, again, I have given a lot of hints in this question. Hint in the sense it is not directly the hint, but the hint to make sure that you at least probably remember the if you even don't remember the formula, I have given the formula, right? So this formula is given here, and also uncorrelated meaning is given. They can easily skip this meaning. They do not need to give this. They do not need to give this. They can directly say this. Okay, they can directly say this because these are inferred things. Okay, they do not need to give these things, right? Okay, so covariance of two random variable xi and xj is 0 actually. Okay, if they are uncorrelated. Okay, that's fine. They are pairwise uncorrelated. So now they are asking you the correlation between these. Okay, so basically you don't need to worry about the correlation. You just need to worry about this covariance and variance because the formula is given to you. Find out the covariance between these two, find out the variance of these things, right? So let's just do this. So covariance between these two will be, I mean, since we have done these kind of things in the class already, so that's why I'm just going through the formula. Okay, here, so it will be x1 will be paired with x2 and x3. So basically x1 x2 x1 x3 and this, right? Now we know if this is basically if this is not equal, I mean, since they are uncorrelated, so that's why it will be just x2 x2. Okay, which is the variance of x2 only, which is given as to be 1 because they are saying that variance is 1 for all of these random variables, right? So this is anyway given to be 1. Now basically this whole quantity is 1, right? Now you just need to find out variance of x1 plus x2 and variance of x2 plus x3. So the formula is this. Okay, variance of x1 plus x2, this is the formula. Variance of x2 plus x3, this is the formula. If you apply the formula, this is 1 given, this is 1 given, and this is also given as 0, right? This is 1 1 and this is also given as 0. So both of these are 2. So again, you can just do this easily. 1 upon 2 into 2 is square root, which is 1 by 2, right? So B is the correct answer. It was also the good question, I can say, right? Okay, so don't worry. So may I saying मैंने ये गलत कर दिया. So don't worry. See, that is fine. Reason is that this was just first AIMT. Okay, this was just first AIMT. So we will be having more AIMTs. Most probably we will be having 5 AIMTs, right? So if we are having 5 AIMTs and this is just first AIMT, so don't worry. I mean, this was just to make sure that you are spending 3 hours, long in the I mean, you are at least able to sit 3 hours. You are at least able to have some focus. You are at least able to recall some things. Okay, so we will be having multiple AIMTs and you will be basically very much comfortable after the 5 AIMTs with the full length test, right? Okay, so this was one tricky question that I can say most of non-go classes students may failed in this question. Okay, so this was very nice question, I can say, tricky or the nice question. Okay, specifically because of this option, stochastic gradient descent is guaranteed to eventually converge. Okay, So we have seen stochastic and the gradient, batch gradient descent. So in stochastic, basically this is very much fluctuating because it is based on just one example. So see here, batch gradient descent is very static. Mini batch is still, let's suppose I'm starting from here. Mini batch is like this. Stochastic is very much unfluctuated. It is too much fluctuating, right? Stochastic. So by the way, this is also in our YouTube channel. I mean, these lectures, stochastic and all. So you can just see these lectures, right? I have solved 30 questions regarding the batch gradient descent and all of this. So you can check these lectures in our YouTube channel if you are not familiar about these concepts. Okay. Now let me move forward. What I'm trying to say. Yeah. So basically, maybe you can see here it is Stanford, right? Can you see this this particular slide? So basically this is the slide again from the same lectures, from these YouTube lectures. Okay, you can see these lectures. So you can see that I've solved these kind of questions, and this question is from Stanford, right? That I've earlier solved. And now you just see the option number C. Okay, is always guaranteed to converge. So in the Stanford also the answer is no. See, stochastic is not always guaranteed to converge, even if it is convex or something like this, right? Doesn't matter. Okay, why? Because stochastic is actually very much fluctuating, so I cannot guarantee. There is no theoretical proof of this. For stochastic, there is no theoretical proof because it can keep on fluctuating. It, for every example, there will be some different, update. Okay, for every example, there will be some different update. You're getting my point? So that is why stochastic is this guaranteed. So actually for the details you can check these lectures. Okay, because since it is just a question solving, I cannot go through the whole concepts and all. So you can go through these lectures for the details. Okay, so yeah, is this stochastic guaranteed to converge? That is the crux of this question. So answer is no, right? I mean, stochastic is not guaranteed, will eventually converge, no. And gradient descent, if it is convex, then gradient descent will converge. Okay, so what is the answer? A is the answer, right? Gradient descent will converge, but stochastic will not converge. I mean, it is not guaranteed to converge, right? If we start, yeah, that is just a luck. So Nikhil is saying that if the initial point itself is the minima, yeah, that is just a luck. I mean, in that case, yeah, in that case, obviously, like your minima, if that is minima, then your grade is zero, right? Already your grade is zero, you will not even run even one iteration, right? Because your grade is zero. You will not even run even a one iteration. I mean, if everything is satisfied. If grade is zero, then this is necessary and sufficient condition. Okay, because the function is convex itself, right? You will not even run even a single iteration of any of the algorithm. So that's why this was a nice question, I can say. Okay. Now let's solve this question. In this question, they are saying that there are like two, data. I mean, two same data, but Alice is recording in some different units, and Bob is recording in some different units, and their resultant data is looking like this. I mean, A, B, C. They are saying these are the two features. I mean, these are the two features and three examples. So these are the three examples: A, B, C, P, Q, R. There will be some Y. Okay, I mean, I'm not writing the Y, but yeah, one of the table is A, B, C, P, Q, R. Another table is 2A, 2A, 2B, 2C, 3P, 3Q, 3R, right? Okay. Now, how many of you found this question nice? We have solved these kind of things in the class also. We have talked about these kind of things in the class also. How many of you remember, or how many of you were able to solve this question in the class, in the exam? See what is happening here. We have two of these tables, right? Now they're asking about the weights if we train using the linear regression. So obviously the weights will be different, right? I mean, whatever weight I'm learning here, okay, will be different. Why? Because here, let's suppose this is x1 x2 here. So basically what I'm saying, that w1 x1 plus w2 x2 Okay, it is giving you some y cap. Now if this was, let's suppose w1, whatever was the w1, so x1, because of x1 it will be, for the first example, w2p, right? Then it will be y cap. For the first example, this will be the case. Now here in the bob table, this is for the allies, right? This is for the allies. Now in the bob table you will be having the same things, okay, but little different. How? Let me just tell you. See, if it is bob, then you will be having w1 x1, okay, plus w2 x2 equal to same y1 cap. But here this w1, it will be, it could be little different, but don't worry about it, I will just adjust it. Okay, w2 3p, right? So it will also give the same y cap, y1 cap. It can easily give. Why? Because w1 can adjust itself. How? W1 can be here. If it is w1, then it will be w1 by 2. If it is w2, then it will be w2 by 3, right? So basically w1 here, if it is w1, if it is giving, if this is giving you w1 w2, then it will be giving you w1 y2 and w2 y3, right? It will be giving you this solution, because y has to be, I mean, they can easily map with the y. I mean, they can easily, this can easily produce the same y1 cap, this can easily produce the same y1 cap. I mean, their prediction will not be different, their weights will be different. Since the predictions are not different, that is why the loss will be same. Because the predictions are not different, loss will be same. Okay, I mean, since the linear regression, it is easy question, don't worry too much. Since the linear regression can easily adjust the weights. I mean, if you are introducing some linear features, you're tweaking the linear features. If you're introducing linear features, your loss will not change. Your weight will adjust such that your loss will not change. Okay, so you can say in one line, your weights will adjust such that your loss will not change. I mean, you will be anyway finding the optimal solution here. Here also optimal solution. Okay, so weight will adjust such that your loss is not changing. Right? So weights will be different, but loss will be same. So what is the answer? C is the correct answer, right? It was really a nice question according to me. Okay. Yeah. So thank you Krishna. So Krishna is saying, sir मैंने टेस्ट सीरीज ली है and वो बहुत ही अच्छी है. So thank you so much for your feedback. Now let's go to the next question. Actually, these kind of things we have done in the class also, right? We've done in the class. Yeah, this question also was a good question. Okay, this was related to k means. This was related to k means loss function. Okay, see, again I have given you the loss function, but there was no need to give that loss function. I mean, the loss function, this is a well standard loss function, right? Again, this was kind of hint, but they may not give it. Okay, so so you might be knowing about the k-means loss function. So what is this? So they are saying first run the k-means. So let me first run this k-means. Okay, if you run the k-mean, then after the first iteration, okay, so this is the initial condition. So you will get to know that, okay, this is one cluster, right? You will get to know that this is the one cluster, because these 2 points are basically, closest to this. So this is the one cluster, this is another cluster. So this is C1, this is C2. Now let's just update the mean. Update means. So if you update mean, then how will it look like? So these are the clusters. Okay, so this particular point, just a second. Okay, this maybe actually, if I just do cut here, it will be black background, but I think actually the mean of the first cluster will be here, the mean of the second cluster will be somewhere here, right? Is this okay to everyone? And these will not be any longer mean. Okay, so basically after mean update, These are not the means. I hope you understood a little bit what I'm trying to say. Okay, so basically what I'm trying to say is that means will get updated. So mean will be this now, mean will be this now. Is this okay to everyone? Now that this is the cluster, this is the cluster, this is the converged. Okay, this has been converged. Okay, there will not be any mean change. Okay, just one iteration, after only one iteration, only after one iteration it will converge. Right, only after one iteration it will converge. Yes, so there was very good topic wise tests also. Okay, to improve the concept. So you can solve those questions first before attempting the AIMTs, because in the topic wise test we have actually covered many of these things, right? Okay, so what I'm trying to say here is that that this is just a converse thing. Now they're asking about the loss function, right? I mean, what is the value of loss? So what is the k-means loss? K-means loss is very interesting. It is basically inter-cluster loss, in the sense that, sorry, intra-cluster, we might call it inter-cluster, in the sense that within this cluster only, okay, for this cluster only, what is the loss? For this cluster only, what is the loss? In the sense, how much it is far from this mean. Since the mean is in the center, so it is 1, right? So it will be like 1 square plus 1 square. It is also one distance, 1 square, 1 square. So basically if you check 1 square plus 1 square for first cluster, 1 square plus 1 square for the next cluster. Okay, for C1, for C2. So finally 4 is the answer. Okay, I mean this will be just 1 and 1, 1 away, then 1 away. Okay, I mean from the mean how much away it is from its own mean. I will not be finding the distance from this to this mean. This is wrong. Okay, I will be just finding the distance. This is a k-means loss. This is taught in the class very well. Okay, this is very well taught in the class, that k-means loss is within that cluster only. Okay, so how much far it is from its own mean. Okay, so basically x, this mu j is for this own mean. Okay, how much far it is from its own mean. This was taught in the class. So these are the 45 questions, which I think number is 45 now. So let's just solve the remaining questions later on. Okay, because otherwise the session will be too long. Okay, I think we have already spent almost 2 hours. So let's just solve the remaining questions in the next session. I will just tell you the timing, okay, for the next session. But let's just solve the remaining questions. So I think 20 questions are remaining. Out of that, for my subjects, maybe AI video solutions are already uploaded. Okay, for AI questions, let me just tell you, for AI questions video solutions are already uploaded. Okay, for example, question number 50. Okay, just a second, let me just paste you, and let me just show you, let me just paste you the screenshot. Let me just show you that what I mean to say. Okay, if you check under the AI questions, so we have already uploaded, we have already commented about the video solution, that AI questions video solution. Okay, so for every AI question, for example, this is the comment under question number 50. Okay, this is a comment under question number 50. So for every AI question we have already commented. Okay, comment under question 50, you will find this particular thing. Okay, under question 50 you will find this comment. Okay, so for AI questions the video solutions are uploaded, and then I will just solve the remaining questions, whatever the remaining number of questions. I think maybe around 15 questions might be remaining. Okay, from my subject. Okay, around 15 questions that we will be solving in the next session. Okay, so thank you everyone, thank you for watching this session, and then let's just meet in the next session very shortly. Yes, AI questions were actually very good. Can you tell me the feedback of the AI class? Okay, I mean, are you enjoying the AI particularly lectures? If you're enrolled students, then can you tell me, are you enjoying AI lectures? How was the AI lectures? Okay, and how was the class? Just let me know quickly. Okay. Yes, the PDF of this I will upload. Okay, PDF of this particular session I will upload. Okay, just after the class. Okay. So thank you everyone. Thank you so much for watching the session. Let's just quickly meet in the next session. Okay. Thank you so much.